Okay, so I'm going to do A1, A2, A3. I'm going to start out by doing A3 first. So let's see how we do A3. Okay, so I1 equals to this, I0. Okay, so I'm going to define I1 minus I0 to be okay. Okay, so I'm going to multiply top and bottom of this by g, the function g. Okay, so I'm now going to do a trick. I'm going to add g squared and subtract g squared over g. So I didn't change anything. But what is this? Is just g, but this is just f. I'm going to keep this g squared. So and I'm going to rewrite this as this. So this whole expression continue here. Okay, now I can combine those terms. And I can, I can gather those terms, and you know what this is? F squared minus 2fg plus g squared. That is just, and this is greater than 0 because the integrand is greater than 0, continuous. Well, so this is okay, so this is our initial step. So we're gonna do so this is our initial well, we don't need to actually. Okay, so we can do this by induction. Now let's do in general. Suppose for some n and n plus 1 is okay. So I'm going to need some inequality here. I'm going to need Schwarz inequality. Well, for those of you who went to high school math Olympiad, what Schwarz inequality says? Well, I need the integral form of Schwarz inequality, which says this. No, I'm sorry, this way. Phew, you're right, it's this way. Okay, so let's see. So I'm going to multiply those two together. And I'm going to see that this is greater than Well, first of all, uh, where do I identify a? A is 1/2. B is 1/2. So this, so squared. Okay, so this is squared. Okay, so that means, well, so that means this equals to what? How do I do that? N plus 1 plus n plus 3 divided by 2. N plus 2 divided by 2 squared. And this is equal to 2n plus 4, which is n plus 2. And this is 2n plus 2, which is gn plus 1. But what is this? This is just n. n plus 1. Sorry, n plus 1 squared. So that means in times in plus 1 is greater than in times in plus 2 is greater than this. Okay, now I can do a inductive step. I can say assume in is greater than equal to, is less than equal to in plus 1, then in order for this hold, in plus 1 it must be less than in plus 2. And that's it. That's you just prove the sequence is increasing sequence. A little bit more is needed to prove this part, but we're not gonna bother this. There's another method to do this problem. Well, you know, if you want to get a full score, you actually have to prove this, but it's, who cares? So second method. There's another way to do this problem, and it's pretty clever. So let's see how that is done. Once again, I need to prove in plus 1 minus in is greater than or equal to 0 to prove this. Well, let's see what we can do here. We still have this. Now I'm going to pull this out. I'm going to pull out I'm going to pull out n plus 1. So it becomes f. Where you see why? Because I put n plus 1 here, so I need a g here. Right? So I need a g on top, because gn plus 1 give me 1 over gn. So this is where this comes from. Okay. Now we know f equals fg, so that means fg equals to 0, right? But this is not 0, by the way, right? Because you have this here, you have integral here. But what we can do now is we can say this is, oh sorry, g minus f minus g. Change anything because this is 0, so this becomes okay. Now we can do something else. We can use geometric sum. So this we can factor this. Integrand. Okay, now let's multiply those two together. Oh wait, yeah, we can multiply those two together because I can do this. I can multiply g. This is just gg, right? Over g f minus g squared, and this is fn gn. Okay. Now we multiply this together. This becomes fn gn plus 1 gn minus, where did I fn minus 1 gn plus all the way f g2 plus. Okay, I'm going to multiply everything by gn plus 1 gn plus 1. It's g squared gn plus 1, so this becomes fn gn plus 1. Okay, so this goes to n minus 1, this becomes g, and fn minus 2, it becomes g2. All the way to here, this is f g n minus 1, and the last one is gn. So f minus g squared is greater than 0, gn plus 1 greater than 0. Everything in here is greater than 0. So this is the continuous function that's greater than 0, so the integrand is greater than 0, so this has to be greater than 0. So thus we had proved what we proved in plus 1 minus in is greater than 0. Okay. Okay, so there's a third method. The third method is you do this. Well, the third method is again, we do in well, we look at in bf. We're gonna say this is the same as this. And this is and we see this is a convex function. So this is always increasing. So those are the three methods to solving the first part of A3.